Begin our park review. So what we're going to do is essentially the end of year park exam, which is what you guys are going to be doing. It's kind of an overview of it, all right? So this video resource is going to be there for you. I'm also going to put this PDF on the website, as well as a PDF of a solutions manual for this that I made last year.
Are those questions going to be
Negative. Yeah.
That's just a test.
So let's begin. We need to know which one of these is equivalent. So first thing I want to do is distribute my I. So that's going to be 2i squared, right? I times 2i. It's 2i squared, and I times negative 4 is negative 4i. We're going to combine like terms. I'm going to combine I and negative 4i. That will give me negative 3i. And then I've got something going on here. Isn't I squared just negative 1? Fantastic. So then I have negative 3i plus 3. This becomes negative 2, right? So 3 minus 2 is negative 1. So choose D, my lord. Yeah. I think the trick to it would be recognizing that I squared is negative 1.
So why is that negative 1?
Why is I squared negative 1? Because this is negative 2, isn't it?
Yeah, and then like 3 plus.
Oh, plus, sorry.
Yeah.
I filled in the correct one, sorry. That should be plus. I must have forgot to put my plus up here. Okay, thank you. Here we go. Number 2. Oh. Number 2.
Oh my god. Number 2.
All right. We're being asked which of the following statements are true about these two functions, f of x and g of x. It says 1 root of f of x is negative 4. I see that and I think, well, maybe if 1 root is negative 4, right? That means that I should be able to factor f of x into x plus 4 times x plus or minus something, right? It means that it should be factorable, yeah? So I'm going to check it and see if indeed it's factorable. It is f of x factorable. So remember, in the top of my x, if I'm going to factor it, I need to use Xbox. And in the top of my x, I'm going to put 2 times 1, right? 2 times 1. In the bottom, I'll put negative 1. That's that one. If it's factorable, there should be 2 numbers such that if I multiply them, I get 2, but if I add them, I get negative 1. And there are no such numbers, right? So it turns out that this is not factorable. Darn. So we can't solve it by factoring. So I look again at my answer set, and I see C says, if f of x is divided by g of x, that makes me think maybe I should divide, right? Maybe they're saying I should divide f of x by g of x. So let's do that. For this particular one, it looks like I can use synthetic division. Why? Because the coefficient of x is 1. And the degree of that is 1 as well, right? Which means I can use synthetic division. So remember when we're doing synthetic division, I'm going to put this 4 here. But remember, it's going to have the opposite sign. Okay, right? It's going to have the opposite sign for doing synthetic division. So let's go ahead and fill in the top. Remember, it goes 2x squared minus 1x plus 1. All right? If there wasn't an x term in there, I would have to put a 0 instead of the negative 1, wouldn't I? Because we always have to have placeholders. But this one's great because it went x squared, x, and then my constant, or my number that's in there. So it's been a long time since y'all have done any polynomial division, right? In this case, we're doing synthetic division. So it's great that we're doing this. It'll jog your memory on how to divide polynomials. So remember, we take this 2 and we drop it down. And then we go 4 times 2 is 8. Negative 1 plus 8 is 7. 4 times 7 is 28. And then 1 plus 28 is 29. You guys remember what that number is? It's the remainder, right? So right away, boom, C is looking good. What does it mean when we divide a polynomial by another polynomial and we get a remainder? It means that it means that whatever we divided by is not a factor.
Like, how do you write that out? Is it like 2x squared?
So check it out. Okay. If I divide x squared, this right here is not part of this problem, okay? Not part of the problem, all right? I'm just trying to explain to you what it means for something to be divisible by another, for a polynomial to be divisible by another polynomial, okay? If I was to divide x squared plus 3x minus 4 by x plus 4, well, what do you think I would get? I get x minus 1, right? I wouldn't get a remainder. I would just get x minus 1. Which means that not only is it a factor of it, and not only is it divisible by it, it's also a factor of it, right? All right. I'm going to erase this because it's a little... That is not working. That was really weird. Okay, we'll just move on. I really want to erase this.
So,
Hold on. Yeah, I'm going to just cross it out for now. I don't want you to look at it while I'm trying to do this other problem. So let's look at 3. All right, 3 is telling me to solve the square root of a equals a minus 6. Whenever we're solving these radicals, the first thing we need to do is isolate the radical, right? This is my radical. A square root of a is my radical. It's already been isolated. It is already by itself on one side of my equal sign. How do I get rid of the square root? I'll just square it, right? Yeah, I'll raise everything to the second power. So I'm going to go square root of a squared, and then if I square one side, I have to square the other side. And be careful, because the most common mistake that people make when they're doing this type of problem is they square the a and they square the negative 6 separately, right? So they say that a squared minus 6 squared instead of a minus 6, the entire quantity squared. Hey, if I square a square root, what happens? I just get that to go away, right? Okay. Now we will multiply this out. I get a squared. A times negative 6 plus a times negative 6 is negative, 12a, right? And then negative 6 times negative 6 is 36. I am unfortunately running out of room here. So I'm going to subtract a from both sides. And I get that 0 is equal to a squared minus 13a plus 36. And I'm actually going to write that over here on the left. All right, guys, this is factorable. Whenever I see a trinomial, the first thing I should always think is, can I factor it? Are there two numbers that if I multiply them, I get 36, and if I add them, I get negative 13? Yeah, I like negative 9 and negative 4. Which means that my solutions are a equals 9 and a equals negative 4. I'm sorry, my bad. Please, eraser, please work. It won't do it either. I'm not sure what's happening. Sorry. That should be positive. That's negative. Sorry. I said negative 4 and real positive. Sorry. All right. So, hey, what's the question asking us? It's asking us what is the extraneous solution? Which one doesn't work? Remember, we had to plug these back in to see if we got a true statement or not. So it's asking us which one is the wrong one. All right. If I plug 9 in for A, I wind up with the square root of 9 equals 9 minus 6. Square root of 9 is 3. And 9 minus 6 is 3, right? So 9 works. Let's check out the 4. For when I plug the 4 in? Yeah, both of these are negative. I made a mistake. Or I said something and wrote the other. So a squared, so I'm sorry, I'm going to plug this in for a square root of a equals a minus 6. I'm going to plug 4 in. So the square root of 4 is 2. And 2 minus 6 is negative 2, right? So if I plug 4 in, I wind up with a statement that tells me that 2 equals negative 2, which is not true, right? Which means that my extraneous solution is 4. Fantastic. Moving right along. So moving on to this next one. It wants to know if P equals 6, what's happening? So let's go ahead, let P equal 6, and see what happens, right? So when P is 6, I have 6 squared. Minus 5 times 6, minus 6, minus, we don't know what x is, right? We know that P is 6, that's all we know. So let's see, 36. Minus 30 minus 6 minus x times 0 equals 0. That's weird, right? This is 36 minus 36, right? This whole thing is 0. That's 0. So what the heck? I guess we get 0 equals 0. That's what? So hey, if we're solving an equation and we get to the end and we get some true statement, right? Like 0 equals 0, 2 equals 2, 4 equals 4 even. What does that mean? That means that you have tons of real solutions, like all of them, right? That means that any number that you plug in for x, gives you a solution. All the way up to infinite numbers. Yeah.
So
Yeah, if at the end we got something like 2 equals 0, if you got something like that, you would choose that one, okay?
So that's why 0 equal to can be like equal to 0.
If you get some number equals the same number, that has it in a solution. And think about it. Think about it right now, okay? At this point, you can plug any number in for x, right? And you'll get a true statement. Any number. Because you're multiplying it by 0, so it's going to go away no matter what it is.
But
So-
don't only have one solution because 0 equals 0.
What's your solution then? No, because you have to get x equals 0. If you get x equals 0, there's one solution. But if your x's go away, and you have a true statement, it's infinitely many solutions. If your x's go away, and you get an untrue statement, then there will be no solutions.
So if it's a number that equals a number, the same number, and then
Yeah, I think there's nothing else that's no solution.
All right. The next thing we're being asked is more complicated. Hey, then what is x? It's saying, hey, leave p alone. Go ahead and solve for x. So that's what we're going to have to do. So I'm going to just copy down the original equation up here. All right. I have to solve this for x. It looks nasty, but if you are clever about it, it's not too bad, okay? So I would like this thing, this negative x, times p minus 6 to go away. I'd like it to be on the other side. So I'm going to go ahead and add this to both sides. What's going to happen? Those are going to go away, right? And on my left-hand side, I'll be left with p squared minus 5p minus 6 equals x times p minus 6. The reason why I moved that over is because I know at some point in time, if I divide both sides by p minus 6 squared, my x will be by itself. And that's my goal. Again, I see a trinomial. What should I always do when I see a trinomial? Factor it. Is it factorable? Are there two numbers such that if I multiply them, I get negative 6, but if I add them, I get negative 5? If you had negative 3 and negative 2, you'd get positive 6.
So if I'm negative, say,
Negative 6 times positive 1.
Yes.
oh,
You were thinking along the right line.
I was thinking,
Yeah.
number.
So p minus 6 and p plus 1. And things are starting to look really nice at this point, because you see there's a p minus 6 on the left, there's a p minus 6 on the right. There's actually two of them over there, but we'll get to that here in a second. So now, the whole plan is to get x by itself, right? X is multiplying p minus 6 squared. If I want that p minus 6 squared to go away, I'll do the opposite and divide. And if I do it to that side, I gotta do it to this side too. So those p minus 6 squareds on the right-hand side are going to cancel. And I will have p minus 6 times p plus 1 over p minus 6 times p minus 6, right? That's what p minus 6 squared is. Well, equals x. And there it is. We've solved for x. We're done, right? Yep, these two are going to cancel out. So which one's our answer? Say again. It's really not that bad. Just don't stress out. Breathe. Make sure you're getting lots of oxygen in your brain. Take deep breaths. In through your nose, out through your mouth. You get a little stressed out. You know how to do this stuff. You just have to think about how to approach this stuff. Right?
Will the formula be on it too?
So that is a great question. Will the formulas be on there? Let's go ahead and get the formulas up for you. These are the formulas that you're provided with. This is your high school mathematics assessment reference sheet. That is what you get to know. Check it out. They have named your arithmetic geometric sequences and series. They told you exactly which one is which.
Cool.
On your test, you had to figure out which was which. Got that quadratic formula. And then the other things on there, and degrees to radians, radians to degrees.
Are we gonna take that on, Mark?
Are you going to have to convert degrees to radians, radians to degrees? It's very possible.
So I can do that, trying to understand other graphs.
We'll get it. We'll get it. Okay.
Where's the loading?
Number 5. It says the solution is given. It wants us to match. So in other classes, it was pointed out to me that it seems like the easiest way to do this problem is to just plug the numbers in for x and see if they work, right?
Yeah. That's usually what I do.
Yeah, solve them. You may use a calculator. We got that decision overturned. So I'm going to go ahead and solve this. Okay, the first thing I'm going to do is I'm going to add a to both sides, okay? And I'm actually going to distribute at the same time. So this a is going to go away on my left-hand side. I'm going to distribute the 4 times negative x and that'll give me negative 4x. And the 4 times positive 5 will give me positive 20. And then a plus a right there is going to give me 2a. What happens when I add 4x to both sides? It cancels. What happens when I subtract 20 from both sides? So what do I have left over on my left-hand side? I just have 0, right? And on my right-hand side, I have 2a, so that means that a is 0, right? If I divide both sides by 2, 0 divided by 2 is 0. So that means that I can write an a right there. Let's solve b. I mean, guys, this is a linear equation. It's algebra 1. This is an easy problem worded in a really weird way, and that's what makes it more. That's the challenging part about it, right? Like, what exactly do you want me to do? All right. I'm going to go ahead and subtract a from both sides. And while I'm at it, I'm going to go ahead and distribute my 4. 4 times x is 4x. 4 times negative 5 is negative 20 plus 1. Okay. So if I subtract 4x from both sides, those go away, right? If I add 20 to both sides, those go away. And I have a is left. All I have left is a is equal to 1. Which means that b goes in the a equals 1. Don't freak out. Don't freak out, but you're not going to put anything in that other box. You're going to leave it blank.
Really?
Yeah.
But it still works if you split it.
Yeah, it would work. Okay. Number 6. We've got some sequences. They give you the formulas. You don't even need the formulas, though. You have to just understand what n is, right? N numbers the term in the sequence, right? So, if we look at this first sequence, -3, n equals 1, right? For 6, n equals 2. For -12, n equals 3. So I just need to plug 1 and 2 into each of these and see which one gives me the right thing, right? So check it out. If I plug 1 in here for n, what do I get? Well, n minus 1 minus 1 is 0, right? So my first term is -3. That means that this one in the top left-hand side either goes with this guy or this guy, right? All I have to do to figure out which it is plug in a 2 now for n, right? So I plug in a 2 for this n. 2 minus 1 is 1, right? 2.5 times 1 is 2.5, so -3 minus 2.5 is 5.5, so this one goes with that one. All right, let's go on to this next one. First thing I'm going to do is I'm going to plug 1 in there. That's going to give me 0 in my exponent. So, because that's the term. Because plugging 1 gives us the first term. Plugging in 2 gives us the second, right? Yeah. So if I plug in 1, I get 1/3 to the 0 power, which is 1. So it's 81, right? Is my first term. So now let's go ahead and plug in 2 there. 2 minus 1 is 1. 1/3 to the first power is 1/3, right? So I'm looking for which one of these 4 has a second term that is 81 times 1/3, or 81 divided by 3. The one with a 27. So there we go. Bam. That one goes there. You would just drag that into that box. We're going to go through the same process. Let's plug in 1. Well, what do you think is going to happen if we plug 1 in? The first term is going to be -3, right? So boom, and then thank you for process of elimination. We got that problem up pretty good. All right. Number 7. Laura's jumping rope for exercise. What good exercise that is, guys? The height of a rope. Okay, this problem looks really complicated. It looks like you need to know trade. You really don't. Let's read the question. We're being asked to select all the intervals. Select all intervals over which there is a negative average rate of change. What does that mean? It means the graph is going down. Okay? So all I need to do is I don't need to know anything about trigonometry to do this. I just need to know that the graph goes down between here and here, and the graph also goes down between here and here, right? So that's between 0.5 and 1 was the first one I pointed out, right? And the other one is between 1.5 and 2.5, which is that one. We have time for one more. It's not that bad. You can think your way out of a lot of these problems. You could also, beware. You could also get caught up in trying to figure out some trig and not realize that the question's asking something much more simple. All right, let's look at this. P of 1 plus 0.02 to the second over 2t. And the problem is, all of our selections over here just have a t. And I need to somehow get rid of that 2t. All right, so this becomes P of 1.01, I believe. 1.01 to the 2t. And now we have to use our properties of exponents. That tells us that we could write this as 1.01 squared to the t power, right? Remember, I can split those up because of properties of exponents. So that is, if I square this in my calculator, I get 1.0201 to the t. Which one is that? C, my lord. And we got a good ways through this today. It's possible to